In this video, we're going to take a look at a priority queue, which is a type of queue that instead of working in a first in, first out format, instead works in a priority format. So the item with the highest priority is the first thing that is removed from our queue. And generally, when we're talking about this, we sort of generalize this idea and we say that the item that has the maximum value is often the thing with the highest priority. So it's a way of being able to remove values in sorted order so that the maximum value that's in our queue is the one that gets removed first. Now, we could maintain something like this using a linked list, right? We could place a value in sorted order in a linked list and continually do that. However, it is actually more efficient to do so using a heap because both our insert as well as a remove are O log n, right? And because they're O log n, it means that we can actually maintain this property of always removing the maximum value very easily. So the idea of our priority queue is basically that it's going to utilize a heap as its underlying data structure. So we're just going to keep track of a heap as our main value. And basically when we add something or on queue to our priority queue, basically all we have to do is we take our value and we insert it into our heap. So we do a self.heap.insert value. And then for our DQ, right, basically all we have to do here is we have to remove the value from the heap, right? So it's the same sort of process. So we would just return back self.heap.remove. And that's our priority queue. When we insert values, they're stored in order where the max priority is at the top of the queue. When we remove, the maximum value is going to be removed from the queue as well. I just realized this, of course, doesn't have a value. It's just a DQ like this, right? And that's really the main things that we would really need for this, but we can sort of like clean this up a little bit. So one sort of improvement that we could do is we could get the size of the heap to check if it's greater than 0 before we actually remove. And if it's not, then we can raise maybe an exception to say that we couldn't remove from the queue, right? Like we did with our original queue, we could do like a, an exception of a queue underflow. And if we wanted to do this, we would have to be able to get the size from our heap, which is pretty easy for us to implement at this point, right? We just return back the length of self.heap and we're done, right? So that's a way of being able to actually DQ from our heap. Now, one other thing we may want to do is implement a peek operator, right, to actually see what's at the top of the peak or at the top of the heap without removing it. In order to do something like this, we're basically going to use the same pattern as our DQ. And in order to get the value that's at the top of the heap without removing it, the easiest way to do that is just to access the heap property and get the value at index 0. That would allow us to peek to see what the top of the heap currently is. And then as a final sort of thing, we may want to get the actual size of the queue itself, in which case we could just return self.heap.size. So this right here is a really simple priority queue. Like I mentioned, basically the whole idea here is that the value that we remove is the largest value that's been added to the queue. So by using a heap as our underlying data structure, we can do this using log of n time complexity. And to help understand why we might want to do something like this, the next few videos will take a look at some example problems that heavily benefit from the process of using a priority queue as the underlying data structure. So thanks so much for watching, and I'll see you in the next video.